Okay, welcome back to Callum's Knowledge, and today we're going to work on the big specialised project. Now, before we jump into the Python code, we need to ask a fundamental question. What problem are we actually solving here? Now, if you ever looked at the world of finance, especially stock markets, you'll know one thing. There is a massive amount of data. Every stock, every second, price updates, volumes, changes, trends, it's non-stop, the list goes on. And for anyone trying to make decisions, whether you're an investor, a trader, or even a student just looking to understand how markets work, the problem is, how do we make sense of it all? That's where this project comes in. Now, the real world problem. Let's say you want to invest in stocks like companies in the S&P 500, which is a group of 500 companies, each with hundreds of thousands of data points, such as opening price, closing price, volume, trends, indicators like RSI and MACD, and many, many more. Now imagine you're trying to go through all that data manually. Not only would it take forever, but by the time you've finished analysing all the data, the market's already moved and you've missed your chance. And of course, it's prone to human error. So the real world problem is, how can we automate financial analysis and make informed trading decisions faster and more accurately using data? So why would we use Python for this? Python is used all across the finance world. It's simple, powerful, and has a massive library of tools specifically designed for finance, data science, and automation. It also connects easily with real trading platforms like Alpaca, which we're going to be using in this project, meaning we can go from analysis to action automatically. And in today's market, that matters. Whether you're an individual investor or a finance professional, automation, speed, and logic-based decisions are absolutely key. Now, the solution is trading bot. The solution I built is a machine learning powered trading bot. And what it does, it grabs all 500 tickers from the S&P 500 directly from Wikipedia, and it downloads historical data using Yahoo Finance. Also calculates technical indicators like SMA, RSI, and MACD, and Bollinger Bands. Then it trains a machine learning model, specifically XGBoost, to predict if each stock is likely to go up tomorrow. And if the model says yes, it places a buy order automatically using Alpaca's paper trading platform. And it even logs all trades in a CSV file, so if you have a history of every action taken. So in short, it turns raw market data into clear predictions and then acts on those predictions using automated trades. Now, why this is valuable? This kind of tool can save a massive amount of time, reduce human error, and help you test trading strategies without risking real money. This uses the paper trading, so we won't be using real money for this case, but you can do so if you choose to. Accounting terms, it's like automating your financial reports, but for trading decisions. It also shows how Python, machine learning, and APIs can work together to solve real-world problems in a way that's practical, hands-on, and scalable. So to summarise, the problem is information overload in the financial markets and the need to make clear, timely trading decisions. The solution is a bot that uses Python, technical analysis, machine learning, and automation to do all the hard work for us. It's safe, smart, and most importantly, something that we can grow and improve on over time. That's the vision behind this project, and we'll continue building this code. I'll walk you through exactly how it's built, step by step. Now let's get into it.
Okay, in today's financial world, data is everything, and having the ability to analyse and trade automatically can save time, reduce risk, and open up entirely new possibilities. In this demonstration, I'll show how Python can turn financial data into real-time trading actions. Now, we begin by installing several external libraries that are crucial for building our automated trading system. This includes Finance, and this allows us to fetch historical market data from Yahoo Finance, and this is free, reliable, and easy to use, making it ideal for research and prototypes. The TA, this stands for technical analysis. and it's a library that helps us compute indicators like RSI, SMA, and MACD from price data. The XGBoost is a powerful machine learning model that's widely used in financial modelling because of its speed and accuracy. Now, the Alpaca Trade API lets us send orders to Alpaca's paper trading platform, which simulates real trading without using real money. Now, additional utilities like PYTZ for time zone conversions, the do10 for secure key loading, and joblib to save machine learning models. Now, after installing these packages, I import them from pandas and numpy which are used throughout the script to manipulate data sets, while date time and OS and time handle environment interaction and scheduling. And the warnings.filter warnings and ignore is used to keep the console clean while executing the code. Now, connecting to the Alpaca API. In this step, I securely connect to the Alpaca Paper Trading API. To protect my sensitive API credentials, I store them in a env file using the do10 library. I load the API key and secret into my Python environment. If for any reason the environment variables aren't loaded, from perhaps running in Colab, the code switches to hard-coded test keys. I then specify the Alpaca paper trading endpoint, and this ensures all trades are placed in a sandbox environment with simulating money. It's completely risk-free and perfect for development and experimentation. Finally, I create an API object using tradeapi.rest, which gives me access to all of Alpaca's trading features. Now we've done all that, we get the S&P 500 tickers. I define this function to fetch a full list of the current S&P 500 stock tickers. This list comes from Wikipedia, which we access using pandas.read_HTML. This is a method that reads tables directly from a web page. Now, some tickers like brk.b, which is Berkshire Hathaway, have a dot in the name, which needs to be converted to a dash. To work with Yahoo Finance, if the web scraping fails, for example due to no internet, the function falls back to a smaller, hard-coded list of popular tickers like Apple and Microsoft, so the script doesn't break. Now, the next part is fetching historical stock data. To make predictions, we need data. Define a function called fetch_data, which uses the yfinance.download method. I specify a start and end date to fetch around 3 or 4 years of daily price data. This includes open, high, low, close, and volume columns. Once the data is loaded, I apply .drop_na to remove any rows with missing values, a common step in data preparation to ensure calculations aren't thrown off. Now, feature engineering and technical indicators. The heart of financial machine learning lies in feature engineering, that is turning raw price data into meaningful indicators. In the generate_features function, I calculate a 5-day and 20-day SMA to capture short-term and medium-term price trends, and RSI to measure momentum and overbought or oversold conditions, MACD to show shifts in momentum, and Bollinger Bands to understand the volatility of the stocks, and daily return and a 5-day rolling standard deviation to capture the recent volatility of this, and also lagged values like yesterday's price and volume to capture temporal dependencies. Lastly, I create a target column which holds a 1 if the price went up the next day, or a 0 if it went down or stayed flat. This target column is what the model will try to predict. So this is the important part. Now the next part is training the machine learning model. Once features are ready, I train an XGBoost model using the train_and_save_model function. And here's the full process. I define a list of features, columns, and the model should learn from. I use train test split to divide the data into 80% training and 20% testing. This ensures our model is validated properly. I then initialize XGB classifier with settings that suppress warnings and specify the loss metric. I then fit the model on the training set and predict on the test set. I then evaluate performance using classification_report and log the test accuracy to a CSV file. Finally, I save the trained model and its features to disk using joblib.dump. Now, we're going to make predictions. This is quite interesting, this. We need to use the predictions using this model. In the predict_next_trade, I take the latest available row of data, which is today's data, and we use the model to make a prediction. 1 means the price is expected to go up. 0 means we should hold off. The result is printed clearly to the console for easy debugging and understanding. Once the bot has made a prediction, it's time to act. That's where trade execution comes in. We take what the model told us and use it to place real simulated trades using the Alpaca AI. Now, the next part is trade execution with Alpaca. This section handles trade logic, and I write a function to check if we already hold shares in a particular stock using the API.get_position. If we don't, and we get a buy signal, we place a market order to buy one using one share using API.submit_order. If we're already holding and the signal says hold, we sell. Now, all transactions are logged using the earlier CSV function, giving us a full trading history for review later. Now, we're going to make this trading decisions now. In the trade_decision function, I combine everything. If the model says buy, we don't hold the stock, we buy. If the model says hold, we do hold the stock, we then sell. Otherwise, the bot does simply nothing. And this ensures simple, clean logic that avoids overtrading or doubling up on positions. Now, the next part is evaluates daily performance using evaluate_performance. I query Alpaca for all trading activities filled today. I display each trade, including the ticker, quantity, side, the buy or sell, and price. This helps verify that the bot is actually placing trades and gives insight into daily performance. So, the next part is we're handling market hours and testing. Alpaca only allows trading when the US stock market opens, right, which is weekdays from 9:30 to 4 p.m. ET. So I use their get_clock API to check if the market is open and also retrieve the current date and time. I add a test mode flag so that during testing or recording I can bypass this and run the bot regardless of time. So because Alpaca has API rate limits and the S&P 500 contains 500 stocks, I define a batching function which splits the ticker into batches of 50 and loop them through, pausing between each batch to avoid getting rate limited or blocked. So previously it was set to the whole stock market at once, the whole 500 stocks, and it doesn't allow that. So the way around this, we set it to 50. This makes the script scalable and ready for large datasets. So we're putting it all together, the main function. Finally, I define main, the function that ties the entire script together. It checks if the market is open, loads tickers, fetches stock data, and generates features, trains a model, predicts signals, and makes trade decisions, logs actions, and repeats the process in batches. Each step is modular, readable, and independently testable, making the system robust and extensible. So, summarising this project doesn't just show how to automate a trading strategy. It shows how you can bring real-world finance, machine learning, and automation together in one seamless system. By using Python and public APIs, I've demonstrated a practical solution that takes in market data, analyses it, makes predictions, and actually takes action all on its own. That's very powerful. Now, this project reflects everything I've learned, not just in terms of syntax or tools, but on how to think critically and build systems and apply them to real financial challenges. Now, reflecting on this, to start with, this module has completely changed how I view programming, especially in the context of accounting and finance. Coming into it, I didn't have much experience in Python at all. I've seen bits of code here and there, but I really didn't know how it all worked together. It seems very confusing. It seems like crazy hacking stuff that cannot be done. But by building a full project from scratch, one that connects to live market data, runs technical analysis and machine learning, and actually places trade through an API, I now understand not just how Python works, but how powerful it can be when applied to real-world problems. The best part was learning how to break a complex idea down into smaller logical steps. I learned how to think like a programmer, to plan my functions, reuse code, test ideas, and then improve them. Now, I'm not going to lie, I did face many challenges doing this. The first big one was understanding how all the libraries work together, getting Finance and XGBoost and Alpaca to all talk to each other properly. Took a lot of trial and error. At one point I couldn't get Alpaca to place any trades. The API keys weren't connecting, so I had to take a step back, reread the document and test everything line by line until it worked. Another challenge was managing the data properly. Technical indicators like RSI and moving averages rely on rolling windows, which means they leave a lot of missing values in your dataset. If you don't handle that carefully, your model won't train properly. I learned how to clean and structure the data to keep everything working smoothly. Now, I also struggled with overfitting at first. My model was doing great in the training set, but poorly on new data. That's when I learned to use a train, test, split, and look at classification metrics like precision and recall to understand how the model was really performing. But, it's led to good news, so every time I hit a wall, we did find a way around it, whether that was testing my code line by line, reading the official documentation, or watching tutorials through YouTube and learning every single line of code. And I kept pushing until I understood the problem and fixed it. And that's where I think I've learned the most. Perhaps not from the course itself, but going out and really just enjoying the class and the Python in general, just going on and learning as much as I could, and then problem solving. Now, how will this help me going forward? Looking ahead, I can honestly say this module has given me real practical skills that I'll be using again, whether it's to send an annoying message to my friend automatically, or make money from perhaps this trading bot if it continues to go well. I understand now the basics of automation, APIs, data processing, and predictive modelling, which are all valuable whether I go into finance, data, analytics, or tech, or just whenever I feel like it. Also feel a lot more confident experimenting with code. I'm not scared to break things anymore because I know now how to fix them. Now, final thoughts on this. Overall, this has been the most valuable and hands-on learning experiences I've had. It's challenged me, pushed me to think differently, and showed me how Python can be used to solve real financial problems. I'm proud of what I've built, and I'm looking forward to taking these skills even further in future projects, further study, or even in a future career in financial technology or for automation when I want to be lazy and want to get Python to do it all for me. Thanks for watching. Congratulations, you've made it to the end of the video, and thanks to everyone involved in the module for making it such a practical and rewarding experience. This was a great task to do, and it was really good fun. Thank you very much. Now, as we see here when we get to the end, I've encountered various issues. This is going to be quite common, especially when it's your first time going through. There will be errors. It would be impossible not to. So most of the errors I have is the wrong indent, which means I've not put a proper space in, or I've even missed a letter, and this can be very frustrating, and it's quite a pain to do. But what you can do is it shows the function to fix error, or you can go to the big Gemini button. The power of AI is brilliant. that can even help you and show where you've went wrong and how you can fix it. So I spent my time doing that and we finally got it working. It took some time though, but once we got it, it's working pretty perfectly. It's working flawlessly. But while we got it working, this code currently takes around 23 minutes. As you see here, it took 23 minutes and 42 seconds for this to be completed, which is a long time, and stocks can change, and the price can change quite drastically. So to improve this model in the future, if we can somehow speed it up or analyse more stocks at once, that would be great. Or even, instead of looking at the S&P 500, maybe change it to crypto or different types of stocks, maybe penny stocks or so on, whatever you fancy, whatever you like. But overall, this seems like a very effective way to analyse the stock market. It's a basic example, but I'm sure you can make it better. Alright, well this has been done in the background. Let me take a second to talk through what's happening and why this matters. What's happening under the hood? Right now, the bot is going through a list of stock tickers, downloading real historical price data from Yahoo Finance. For each company, it's calculating technical indicators, and like RSI, MACD and Bollinger Bands, which are tools that real traders use every day to understand market behaviour. Then it's also cleaning up the data, removing anything that might throw off our model, and getting everything into a structured format. And then it moves on to machine learning, training a model from scratch using XGBoost, which is one of the most trusted algorithms in the industry. It's learning the relationship between technical indicators and future price movement, specifically whether the stock is likely to go up the next day. Once it is that prediction, it decides whether to place a trade, and it actually submits the order through Alpaca using paper money. Now why this matters, the big benefit here is automation. Instead of manually analysing 500 stocks, this bot does it all in the background. That saves time, reduces error, gives you a consistent data-driven approach. Because it's using paper money, we can test all of this safely without any financial risk. Now, getting to this point took a lot of trial and error, especially around connecting to APIs, handling missing data, and managing time zones for market hours, or simply me misclicking buttons. But that's the whole point of this kind of project. It's not just about writing a code, it's about thinking like a system builder. Now, the cool part of this is it isn't limited just to the S&P 500. With a few tweaks, I can apply the same logic to the FTSE stock, the FTSE, crypto markets, or even commodities. So I can even, let's say I want to trade with gold, crypto, or another index fund. You can also expand it with features like stop losses, profit targets, or portfolio management rules. Don't forget, everything is logged. Every buy or sell the bot makes is saved to a CSV file, so I can look back and track the performance over time. So while it may look like we're just waiting here, the bot is actually doing a lot of work behind the scenes in every part of it, from the data scraping to the model training to the actual trade execution. It's designed to simulate what a real trading system would do. Okay. I'll show you what this looks like on the paper AI. So from £100,000, made about 700, it says there. It's not a lot, but this has only been from March 26, so around a week, this is here. And this shows you all the top positions it's been made. You see the profit, loss as well. I'll just look through all this so you know it works. It shows you the recent orders, which was recently made. As you see, it's a lot of purchases, a lot of orders. And we will also go to balances. You see it's all here, what we're working with, what's been happening. And then we'll go to activities. And there's all that's been bought so far. Right. Then we'll go to, oh not that one, positions. And we can see the total profit and loss percentage. So you see it's looking quite good. We can maybe improve it some more, but this is looking quite nice.
That now brings us to the end of the specialised project. You've now created a successful trading bot. This has been a very long journey for all of us, but what you need to do now is keep learning and stay curious.